Hello, viewers. A very happy morning or happy evening or whatever time you're seeing. A happy greetings to everyone who is watching this. Well, in this video, the PPT presentation done by me, which is Deepak Kumar, a student of PhD Arts and Science College, is going to explain about erythorbic acid, its characteristics and fermentation process. Because everybody knows that erythorbic acid is a fermented product of a certain organism and its process, which we'll be discussing further in this video. All right. So what is erythorbic acid? It is actually also called as erythorbate, which is also formally known as the isoascorbic acid, which is a stereoisomer of ascorbic acid. All right. So I think everybody knows what is stereoisomer. It means let's compare two molecules where both the molecules will have same molecular formula but different structural formula, which means there might be some changes in the bondings or might be changes in their optical illusions, everything. All right. So from this we can get an idea that erythorbic acid is nearly similar to ascorbic acid, and as we know that ascorbic acid is the biological name of vitamin C. All right. So it is produced by a reaction between two keto D-gluconate and sodium methoxide, and it can also be synthesized from sucrose, right, which is a disaccharide, but major productions is done by strains of penicillium species. And everybody knows, right, penicillium is a common word in the mouth of scientists, right, because it's it was discovered by Alexander Fleming and it's used as an antibiotic all over the world, right? And erythorbic acid was first obtained or extracted in 1960 by Takahashi and his colleagues as a cultural metabolite of a particular strain called FY117 Penicillium notatum. Now, to give a specific information here, it's actually a secondary metabolite, which means it was produced during the stationary phase of the growth of the penicillium, right? Because we know primary metabolites are produced during the log phase, but this was produced during the stationary phase. That's why it is considered as the secondary metabolite. All right. And down you can see the structure. It has got a pyrene ring, and along with that a lot of bondings with a lot of hydrogen and oxygen. And to go for the market potential, as per Volza's global export report or the data, the erythorbic acid shipment stood at 1.1k. It's a huge number, right? Depending on its growth, and exported by 189 exporters. Now, world exports most of its erythorbic acid to USA, obviously India and Vietnam, because everybody knows that India is known as the pharmacy of the world. All right, so it is an important ingredient for all the pharmaceuticals produced in India. So obviously India is an important importer of erythorbic acid. And the top three exporters, obviously the name suggests, China, US and South Korea. And the top international companies which export or manufacture EA are the China's Changzhou Coumarin Fine Chemicals and US's Revlon Manufacturing Limited, whereas India's top erythorbic acid producer is Recon Organics Private Limited, which is in Vadodara in Gujarat. Now let's go for the properties. The molecular formula C6H8O6, which states that there will be a lot of double bonds in it. All right, and the molecular weight is 176.12 gram per mole. The appearance is shiny granular powdery crystals, sometimes white and sometimes yellow color, depending upon how it has been eluted during the extraction process. All right, and odor, it's odorless. pH is 5 to 6, which is acidic. Obviously the name itself clarifies that it's an acid. And the density is 704 kilogram per meter cube. Now, boiling point, melting point and flash point. It's important that sometimes people get confused regarding this. All right. So boiling point is nothing but here, whatever substance it is, if it is in a liquid phase and by certain temperature, its liquid phase changes to the gaseous phase is what boiling point means. Okay. Liquid changing to gas at a certain temperature. So here the boiling point is 227 degrees Celsius, and melting point means the substance in its solid phase, right, by a certain temperature is changing to a liquid phase. That's what melting temperature or melting point means. And for erythorbic acid, it is 164 degree to 172 degrees Celsius. And flash point is nothing but, we have to understand, it is actually the lower temperature or the temperature at which it gives off some vapors, which will ignite in air if ignition source is present. Okay, remember that that is a slightly different from auto ignition temperature, because flashpoint requires an ignition source, to ignite. All right, and auto ignition temperature means it is something same like flashpoint but without an ignition source. It's a temperature where without an ignition source it will start burning. All right, that's the major difference. So remember, flashpoint will have the least temperature when compared to the auto ignition temperature, because lower the flashpoint, greater the fire hazard. All right, so here the flash point is 169 to 172 degrees Celsius. All right, and the solubility is, obviously it is soluble in alcohol, pyridine, and in water it's nearly 40 gram in 100 ml, and it will be soluble at 25 degrees Celsius. And the IUPAC name, obviously the International Union of Pure and Applied Chemistry name, is something very big. All right, it is 1,2 dihydroxyethyl 3,4 dihydroxyfuran 25H1. Okay, that is depending on the bonds. And safety and hazards, it obviously causes skin irritation, eye irritation. Mostly, it causes irritation, or it makes problems towards the pupil, towards the iris, so that sometimes people become blind if the exposure has crossed its limit. All right, and also respiratory irritation, because once inhaled it goes to the alveoli, right, starts accumulating there. And obviously we know that alveoli and the veins, I mean especially the arteries or the veins which passes through the lungs, has something called as the gaseous exchange process, right, the respiration. So obviously this gaseous exchange stops or gets reduced and people start suffocating. All right, and incompatible with chemical active metals such as aluminum, copper, magnesium, and zinc, as well as it's a strong oxidizing agent, which means it will try to remove the electrons from the outer shell of any substance, which means it is making the whatever substance going nearby, it is oxidizing them. All right, it's making them positively charged. Okay, it's removing its electrons so that they become even more hyperactive and start reacting to other things, and obviously the chain reaction goes on. And the storage, right, it should be stored in airtight container, it should be protected from light, and obviously in a cool and dry place. Now this is the biosynthesis pathway, and as we know that most of the erythorbic acid is being produced from the yeast, I'm so sorry, it's the penicillium species. All right, also some plants also do produce it. So this is the pathway. So it starts with glucose, then under the presence of enzymes, it goes converted to mannose, right? Then guanosine diphosphate dextromannose, then the levogalactose, then L-galactose, L-galactono 1,4-lactone, then the ascorbic acid. Now this ascorbic acid is what stereoisomerically changes to erythorbic acid or changes to ascorbic acid, depending on the concentration in the organism which is producing it. So this is how the synthesis, biosynthetically it is produced in the living organisms. So the production, it is produced, as we have seen already in the first slide, it is produced by reaction between 2-keto-D-gluconate and sodium methoxide. It can also be synthesized from sucrose, but major production is done by strains of penicillium species. And as it was obtained first by Takahashi et al., and it's a culture metabolite of a particular strain, as we know already, FY117 Penicillium notatum, and mainly produced by plants and fungus species like strains of penicillium species. Now the raw materials required, especially the substrates required, are gluconic acid, glucano-Y-lactone, glucano-8-lactone, sucrose, maltose, and starch. As we know that sucrose and maltose are disaccharides and starch is a polysaccharide. So these requirements are a must. And if you see the composition, mostly there are the nitrogen sources, because carbon source is only one, nitrogen source and the trace elements along with minerals are required more, because here osmotic pressure becomes the most important factor in the culture media. All right, so that is why the culture media, whether it's a main culture or subculture, requires a lot of phosphates and sulfates and carbonates in order to maintain the osmotic pressure. And the pH should be 5.4 to 5.5, and obviously the cultural incubation time is around 48 hours, and the cultivation temperature is at 30 degrees Celsius. Now wild strain and strain improvement, it's important to understand that the wild type strains will produce a certain amount, all right, but we know that in this era of faster production, in this era of greater production, all right, we have to improve the strain so that they produce a larger amount of erythorbic acid so that it can be utilized, right, for other purpose and in a faster way. So the wild strains include the Penicillium notatum, the Penicillium decumbens, the Penicillium Cynium, and the Penicillium charlesi. But and for the strain improvement, especially the FY115 strain, which was used as the parent strain by Takahashi et al., they used some methods in order to improve the strain, so that the undesirable products are produced less and our product of interest is produced more. That is through monospore selection, through UV radiation, obviously, by making some changes in the genetic makeup of the individual, where only the desirable products are produced, right? The nitrite treatment and the monoiodoacetic acid treatment. Now, the fermentation types, it includes two ways. One is the direct fermentation method, which is the jar fermenter, which most of the products are produced, and the second is cell suspension method, which is mostly used for vaccine production. All right, but yes, for erythorbic acid also it can be used. So let us go through what are these processes actually. Now, for direct fermentation method, right, the carbon source required, it depends on carbon. So let's say the carbon source is high, obviously the production source will be high, but till a certain extent, because there is something called as optimicity. All right, so if it goes beyond, let's say the substrate goes beyond the optimum level, the production will be same, not more than the optimum level. All right, so the optimum low and the optimum high is 0.5 to 10%, but sometimes the concentration is kept at 0.5 to 1% for continuous culture. So the other substances present in the media are organic as well as inorganic, right, which are mostly the nitrogen sources, which we have seen before in the composition of the media, and also traces of metals are also required. And regarding the pH, it is 3 to 7, which has to be maintained. The time required is 5 to 10 days, right, for the surface culture, but if it's submerged culture, it will take nearly 3 to 7 days. And the preferred temperature is 26 to 28 degrees Celsius. Whereas for direct cell or the cell suspension process, right, the requirement of carbon source is 0.5 to 10%, right, the pH is 4 to 6, the temperature is 30 to 35 degrees Celsius, and most importantly, the time is just 50 to 80 hours. Why? Because we have to understand that cell suspension is nothing but we are preparing a true single cell suspension of our sample, which will optimize our cell separation by avoiding additional cell loss and enabling maximum labeling of the target cells. All right, this is what cell suspension has been planned for the fermented products to happen. All right, so the concentration can be kept, but the problem is that the time required for the production of our product of interest is less, right? But the production also will be less. And this is the recovery process where the broth is taken, it has been filtered, the filtrate is passed through two things, right? As we all know that ion exchange chromatography should have a stationary phase, right? And through two processes it happens. One is the anion exchange resin adsorption or the cation exchange resin, because here the resin acts as the stationary phase, right? Our eluent, right, has the erythorbic acid present in it, so it is passed through the stationary phase, right? Whatever is our product of interest will get attached to the stationary phase, and the other products will come out, so that then slowly we can take, or let's say take out our eluent, right, which is our product, right, so that that can be concentrated, it can be crystallized, and we will get the mother liquid as well as the crude crystal. So if you see all the methods, we can see that the yield has reduced from 100%. Some yield is 53, some yield is 56, right, 14. Let's say the erythorbic acid in mother culture is 8.3, 5.8, 86. So why this variation? Why such, despite doing all sort of purification extraction process, right, it is showing lesser amount, right? We'll see this in the further slides. So from the results, it is clear that the cause of decreasing yield of erythorbic acid was due to contamination of HCl in erythorbic acid containing eluate, because we know that we used a resin which acts as the stationary phase, right? And the eluent, right? The eluent which is used, right, is the erythorbic acid, which is having 1N HCl solution, because HCl solution is the one which helps, right, cause elution of our product of interest. All right, so that is why, and as it is present in the erythorbic acid, obviously it will cause some decomposition, and obviously we won't get that refined product as we want, that is the erythorbic acid. All right, so again we have to separate the erythorbic acid from HCl by difference in selectivity of ion exchange resin to the desired ion, right? Because elution is done first, then extraction and purification. Now here the crystallization is done, or let's say concentration is done in vacuum, because we know vacuum, whatever substances are presented in vacuum, right, it gets crystallized soon. Why? Because vacuum sees the vapor pressure of the substances, what is subjected to it. All right, let's say water and solid. Water has the least vapor pressure, so it gets evaporized quickly, like let's say it gets sublimed, okay, quickly. So that is why in space, you would have seen in movies that whatever things are sent in space, they become cool, they become crystallized, they become brittle, right? As if you are putting your hand in liquid nitrogen, if you take it out, it becomes like a stone, right? Like solid, it becomes within 2 seconds, like that. In vacuum also it happens the same thing. So vacuum is one of the best method to crystallize, or take out the product of interest, especially if you're dealing with substances which is actually a mixture and it has different vapor pressure in it. All right, so here the recovery products are 90.9% of crude erythorbic acid, which you have seen earlier, which contains 71% of erythorbic acid, 19% of sodium salt of erythorbic acid, and 4.5% of erythorbic acid solution of the hydrochloric acid. Alright, so from this you can understand that from 100% we are getting 90% of the crude item, and from the crude item it's actually 71% which is purified. Remaining 19% we have to undergo distillation, extraction, a lot of things, so that we can at least assimilate or absorb more of EA from that and get the more amount from it. So last, the video is gonna end with its application, right? It is used as an antioxidant in brewing industry, because antioxidant helps in destroying the radicals, which actually come with the purpose of destroying whatever things are in the environment. All right, and brewing industry, obviously, as or living organisms are utilized in them, so radicals destroy them, so it is used as an antioxidant. So second, it has antiscorbutic activity, which means from the name we know that ascorbic acid is vitamin C, and if there is lesser amount of ascorbic acid in our body, we will suffer from a malvitamin disease called as the scurvy. All right, where our gums will start bleeding. That's why people used to say have citrus fruit, because it has ascorbic acid in it, so that you won't bleed your gums. So it has this antiscorbutic activity. Second, the third, it is used as a reducing agent in photography, right? Reducing agent in the sense provides a lot of positive ions, so that the photos, right, becomes even more clearer, brighter, with proper definition in it. It is used as an antimicrobial agent in food. It's good actually, and it is used in oral pharmaceuticals, because we know that uh, medicine which has a lot of coatings in it, right, it is done using erythorbic acid. We know that there is an active ingredient in a medicine, it has got a lot of chemicals being coated in it. So erythorbic acid is one of it which is coated in it, because once we take the medicine, it goes to the small intestine, and from there it gets assimilated and absorbed and goes to the target area. So this erythorbic acid helps in coating a proper area, so that we can use our drug to our organ of interest. So it is used, erythorbic acid is used in that purpose. It is used in paint and coating additives, right? It also acts as a corrosion inhibitors, because the corrosion means it's rusting. And also it is used as an anti-scaling agent. Anti-scaling means, let's say, scaling means deposition of minerals on certain substances and products. So it causes a lot of tear and wear loss to the instruments in manufacturing industries, or let's say production industries. So erythorbic acid is used directly, so that these scales are removed and the machines work in a proper manner. And last one, it acts as a surface active agent, which means it keeps the surface in an active form, so that if we want the reaction to take place on the surface of certain things, yes, erythorbic acid is the best agent to do it. So due to its various application, its valuation is nearly $22 billion in the world, and it is rising at a faster rate. And so this is where the video ends. I hope you would have liked it. Thank you so much. Have a good day.